Bye. Hey, bye.
All right.
Oh, why you guys coming on alone together?
Chapter 2. Either hopefully you have the book or get on my website and look at the pictures. This is page 45, question 59. We did not practice a whole lot with graphs. So it's kind of something that I'm just assuming that you can figure out or you already know. So 59 is a good review of a position time graph. So it says figure 2-34 is a position versus time graph for the motion of an object along the x-axis. As the object moves from A to B, it says part A, is the object moving in the positive or negative direction? Negative. It's in the negative direction because you have a negative slope, right? Pointing in the negative direction. Part B, is the object speeding up or slowing down? For that, you look at the curve, right? If it's getting steeper, it's speeding up. It's speeding up in part A to B. For part C, is the acceleration of the object positive or negative?
Negative.
Right. Why is it negative? Okay. Let's not talk about the slope on a position time graph is velocity. Here's how you figure out that the acceleration is negative. The object is moving in which direction? To the left, the negative direction, right? And we said it's speeding up, right? For it to be speeding up, the velocity and the acceleration have to agree in terms of sign. So if I'm moving to the left negative, then my acceleration also has to move to the left negative. Has to point in the same direction. Both have to be negative. That's how you answer that one. You can't look at the slope and figure out if it's negative or positive. You have to look at the velocity, the sign of the velocity, and the acceleration has to match the sign of the velocity for it to speed up. They have to be opposite to slow down. Right? It says next for the time interval from D to E, D is the object moving in the positive or negative direction. That's positive. Is the object speeding up or slowing down? Once again, it's speeding up.
How's speeding up?
Your slope is getting steeper. It starts off relatively flat, and then at the end, it's steeper. Right? Is the acceleration of the object positive or negative? This has to be positive. Velocity is positive. It's speeding up. Acceleration has to agree and be positive as well. And it says, finally answer these 3 questions for the time interval from C to D. Well, C to D, what is the object doing?
Nothing.
It's just staying still. So no acceleration, no velocity. It's not moving in the positive or negative direction. It's just staying at a constant position. So that's 59. Page 45, number 59. Right. Another way you could tell the velocity is 0 because the slope's 0. So chapter 3, are there any you wanted me to work out? 36.
Wait, I have one question.
Yeah.
Oh, you know how you give us the range formula?
Yeah.
You have to know how to use that.
I don't think that's on your test. I can double check. You might be able to use it. I'm sure you'd be able to use it, but I don't think you have to. Like, it's not the only way to solve a problem.
What's the problem? Because I got the wrong answer and I did it the other way.
You did the other way and you got it right. So you just want me to work all of 36?
Yeah.
Okay. We can do all of 36. All right. Let me pull this up so I can look at it. Okay. I will do it. Now this is a pretty standard projectile motion problem. Nothing too tricky.
You're standard.
What's the D and E?
This is 38.6 on page 73. All right. Oh, let me get a drawing of this going. Come on. Who moved this? Kevin.
I didn't even move it.
Kevin moves it all the time. Okay.
Oh my gosh. I hate
All right.
you.
So here we have an object launched at an angle. So the very first thing that you should want to do with an object launched at an angle, is split it up into its components. So this is, let me get the right thing. This is 105. Oh, this is way off. I know. 105 meters per second at 37 degrees. So I would say before you try setting this up at all, do 105 cosine theta, not theta, cosine 37, and 105 sine 37. and break that into components because you really can't do anything without those. Do that while I calibrate this thing because it's gonna.
Shouldn't cosine be 83.857? The sine should be 63.
Did you use the identities? I don't know. I haven't worked it out.
No, I plugged in my calculator.
This is page 73.
Yeah.
Yeah.
What number? 35?
36. Calibrate this thing.
How fast is Sam's going?
105 at 37 degrees. All right. So when we do this,
I just told you the answers.
well, I'm gonna double check.
Oh, okay.
Okay. 83.857, and then this one's gonna be 63.191. Okay, so that really should be your first step, and you can label this as Vx and label this as Vy initial, because we know the y velocity is going to change. The x will not change. All right, so moving forwards, in terms of what we're given, we know Vx, we know Vyi, and we also know delta y is 125 meters from the height of the thing.
Negative 125.
All right, you can say negative.
It
Let's
is
do that.
negative.
All right, we'll do that.
Yeah.
All right, that means our acceleration in the y direction has to be negative as well for it to agree. Okay, so for part A, it says determine the time taken by the projectile to hit point P at ground level.
Where'd you get it?
So this is actually a good time for me to show you how the calculator can be used here. All right, if I want to determine time and I know delta y is negative 125. Okay, I know, what was the initial y?
Initial y is.
It was 125.
Point what?
191. Oh, Vy.
Okay. I know these things, and I know my acceleration is going to be negative 9.8. What I can do is go to my delta s equation, and I can set it up as so. Negative 125 equals 63.191 t plus 1/2 negative 9.8 t squared. All right, I told you the complete wrong way of solving this because I'm an idiot and I forgot that this is a quadratic and you can't factor a quadratic.
Yeah. I was telling you the whole time, but you're like,
No, you're right. Okay, so you can use math or the quadratic formula to solve for this, but that's a pain. The easiest thing that you can do here is set this equal to 0. Right, so you'd say 0 equals 63 point, why is it not right? 63.191 x, replace x with t, plus, I'm going to do negative 4.9 t squared minus
Should we plus?
or plus 125.
And then use the quadratic formula.
No, I wouldn't use the quadratic formula. You all have graphing calculators. What I would do is replace the 0 with y and put it into y equals in your graphing calculator.
Wait, girl, give me some math.
Okay, and unfortunately I can't show you this, but you do 63.191 x
So do I just quit
minus
that?
4.9 x squared plus 125. Make sure your graphs are turned on. I've got stuff in mind.
Dude, my graph is like off my graph.
Yeah. Hold on.
Do I have to change my x value?
If you do zoom 9, that'll usually get it to fit. If not, hold on. Yeah, mine's off my graph too.
You lied to me.
I did lie to you.
Alright. My bad.
What does that mean?
CrossFit. Because otherwise I catch strap.
It's not zoom 9. What is it? Zoom.
No, it's window. It's window. That's how you calculate your minimum and maximum.
Wait.
No, but there's a way to get it to show up on the screen.
Sir,
Zoom
no,
zero.
You could have just
Zoom
considered
0? Yeah.
You should have just considered it 0 and just figure out the time.
Considered what 0?
Like, don't, like, just think of it as on the ground and then find the maximum height that it's going to go to. And the time it takes to get there. Like, because this is like a normal parabola and then it has the thing from the bottom.
I see what you're saying. You can't assume that it's on the ground though, because it's not.
I know, but like, it's just a parabola and then it has more. Like, if you set the origin at 120.
I know what you're saying.
Yeah.
Okay, so I know June did this on his quiz. If you look at the picture, you can see it's already set up to where there's one parabola. Basically, the thing goes, I'll draw a little picture. If this is the cliff, the thing goes so far up and then comes back to the same height, and then it falls further. So I know what June did once is he found the time here, and then he found the time to fall from this height, and then he added them together. Okay, that works. I'm trying to show you how to do it in one step.
Hey, I'm trying to do negative b like that.
Sorry?
I'm trying to do
Did I? I think also typing this in the right way would help. So what you'll get is a graph of the motion of the object, and what you'll do is second calc, and you're going to do 0. And then you do the, hopefully you know how to do the left and right bounds. I'm doing this on my phone.
You get 14.6. What the heck?
No, that doesn't sound right.
14.64 seconds. You don't sound right.
You don't sound right.
You don't sound right. Amazing.
3 points.
I'll go look at the chapter 3 syllabus. No, I am right.
I grabbed
It is
this wrong.
14.6 seconds. It is 14.6
What?
It is 14.
Yeah, we are. I want to show you how to do this in the calculator though. Apparently I'm not doing it right.
Conventionally, it is 14.6 seconds. You just graph it and you find the zero. Why do you guys?
Yeah, but this is not graphing correctly. Did anyone get it to graph?
Well, maybe you could put the negative 4.9 t-squared first. I don't know.
That's what I tried doing.
I'd rather just do this.
Put it in the quadratic format.
Well, yeah, you have to. I did a whole.
I don't know why this isn't showing up correctly.
You don't. You have the X.
Yeah, I've made that mistake before. I'm getting a 0, but it's at 0, 0. Interesting how realistic it looks. Well, I know it's a parabolic path, right? Yeah. I don't know why I'm not getting.
Is it the view? I thought you said. No, actually, probably is right. Here, I'll do it.
Sorry? What did yours look like? Yeah, you got the right answer.
I did it too because I didn't figure out why.
Okay, then mine's. I think it's just my phone being stupid. So if you put this in the calculator, you should see a parabolic path. You're going to have one time value, 1 0 in other words, at a negative x. Throw that one out. You calculate the 0 for the positive time value. What do you get for t? 639 seconds. Okay, so that would be your first step. That's part A. Determine the time. Okay, determine the range. Is pretty simple. Now that we have time, we know that in projectile motion, our velocity in the x direction is constant.
Vx equals
80,
delta s over.
what was it, 80 something?
Oh, 80.
80 what? 857 meters per second. This is a constant velocity, so I can just do delta s is equal to, v is equal to delta s over t. Right, solving for range, which I'm going to say is delta x, is v times t. Right, so you just do this velocity times the 14.3 whatever, I don't remember what it was. This the time we had before. All right, that's finding the range, which is pretty simple. Determine the range at the instant just before the projectile hits point P, meaning the ground. Find C, the horizontal and vertical components of velocity. All right, so first, the horizontal is easy. What was 83.157? 857. The horizontal doesn't change. You don't have to find that. It's constant. The vertical does. There's probably a lot of different ways you could find this. You can, yeah, it's accelerating, gravity. Right, so Vy final, there's probably a lot of different ways you could solve for this. Since we solve for time, you could use that and you could do this. Vf is equal to Vi, which we also solve for, plus At. You could get the final velocity that way, or you could do it this way. Actually, yeah, V naught squared plus 2a delta y. That would also work because we know delta y.
Are we on the C?
Yeah, this is part C.
The C is just asking for final velocity.
Final velocity x and final velocity y. Final velocity x is constant, so we don't need to solve for that. Final velocity y we do need to solve for, and there's two different ways. This is using, so if you didn't think that you solved for time correctly, you would want to use this one, because it doesn't have time. This is using just what's given in the problem.
So,
Delta y is your height, a is negative 9.8, VO is what you solved for when you did the trig functions.
Did they ever say components when they say final velocity?
No, I know it's final because it says at point P. And you see in the picture point P is where it hits the ground. That's why it's final. Okay. Part D, the magnitude of the velocity. This is, for finding magnitude, what you would do is you'd say V final is equal to the square root of V x final squared plus V y final squared. In other words, what? Yeah, the hypotenuse of your triangle Pythagorean theorem. And then for the last part, part E, the angle made by the velocity vector with the horizontal, you could do this a lot of different ways, but I would say since you solve for VXF and VYF, right, this would be VX final, this would be VY final. Yeah, I just drew it out weirdly. Okay, we would solve for the third side, that's the true velocity, and then you would use the tangent function to find that angle. Second tangent of y over x. Let me make sure it's y over x though. So our projectile comes in like this. We would know this would be V xf. This would be V yf. We want this angle. Yeah. It would be tangent y over x. Going back to vectors, so that's 36.
Wait, what about D?
We did, that was, D was this. This is part D. Yeah. So like in any projectile motion, really we're going to look at the x and y velocities separate. But if you want to find out how fast it's really moving at any point, you find the x and y velocities at that point and then use Pythagorean theorem. And you'll get that velocity at whatever angle, theta here. Were there any other projectiles you want to work on?
Oh, so it's the magnitude. Oh, it's just the height. Oh, okay.
Are we good with the chapter 3 problems other than 36?
Wait.
Yeah. 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 We already calculated, this is constant, right? Your velocity in the x direction is constant, so it's whatever you started with. This we found, you could use this finding the time independent equation, or you could use this finding the time, or using the time that we solved for. There's a couple ways you can find that.
Wait, can you do number 68?
Is that in chapter 3?
Yeah.
Oh, I remember.
I mean, like, okay, I got the right answer, but then, like, the way the book solved it was really weird.
The Babe Ruth one, is that what you're talking about?
Yeah.
Okay.
1 meter.
This is a good one. So, projectile motion. It says when Babe Ruth hit a homer over the 12-meter high right field fence. So here's the fence. 12 meters, right? There's our fence. It says it was 95 meters from home plate. Roughly, what was the minimum speed of the ball when it left the bat? Assume the ball was hit 1 meter above the ground. So over here we have another delta y of 1 meter. And 40 degree angle. Okay. So it is, what you have to assume is, since it's saying minimum speed, you have to assume that it is just clearing the fence. All right, so you basically solve for it hitting the fence. And that would be the minimum speed. Working with what you're given, I'm not exactly sure where to go from the start. Let's see.
Can you change x as your x on your 40 degree
You have to use
No.
delta y is 11 now.
Yeah, so the first thing you can say is, yeah, since he's hitting it at 1 meter above the ground, your real delta y is 11 meters. Okay, so if I know a height, the very first thing that I'm going to want to do is the delta y equation, delta s equation. So you're going to say 11 meters is equal to, we don't know the initial velocity in the y direction. We do know a. Okay, so we need that initial y velocity to get time. So that's not going to help us.
You could,
Wait, isn't it 4.9?
Sorry.
Are we solving for the other one? Is that like
No, the question is, what is the minimum speed of the ball when it left the bat? So what we want is this, the resultant. Yeah.
so you go cosine and cos of x, because it doesn't change.
Well, we'd have to know this though, to get the x.
See, this is what the book did. Like, it said so it did initial velocity cosine 40 equals 95 over time. That's what the book said.
Oh, okay.
But like, can you explain how
Yeah, but is that gonna hold on? Where's that gonna get you?
it gives you initial velocity times time equals 1.4. So you can substitute that in the IT.
Oh, yeah.
68.
But I mean that equation came out of nowhere.
Oh, I see what they're doing. Wait, do I?
Substitution. Really.
Yeah, they're substituting in, but I don't think you need a substitute. I mean, obviously you can.
Yeah, but like, yeah.
Well, you're essentially substituting what you solve for.
Right.
Unless you can eliminate a variable.
Hey, do you see? What is the
Wait, we can simplify this. I don't like substituting unless you really have to. All right, so let's simplify this drawing. Wait, is this gonna work? No, it's not gonna work. So we don't know max height. That's not gonna work. I thought they gave you more than.
Nope.
No speed of the wall.
Wait, can't we assume that? What? The test is easier than this?
Huh?
The test is easier than this?
I don't know. Sure.
Okay, so like, you think it's
12 is equal to 1.
I really want to know how we would compare when it comes to frequency.
Yeah, this you don't need to know how to solve this problem. I see what they're doing.
So we just don't.
Don't worry about 68.
I don't know, it's freaking out about.
I thought they gave you an initial velocity, which if they did give you an initial velocity, you would need to know how to solve for that one.
But if they give us an initial velocity, it'd be really easy.
Yeah, it would be.
They don't. So it's all about that.
What they're trying to get you to do is,
Derive it.
I'm not even sure. They're saying so the initial velocity times time in the x direction has to equal VO cosine 40 degrees. Yeah, see, that doesn't even make sense to me. Yeah. No, they're supposed to be hard. I've made all of them so far except the review.
There was a review quest?
They have a review quest. I asked you guys and you said you didn't want one, so I didn't.
No, I said I wanted one, but that wasn't due. For an actual grade. I just wanted a review.
No, I just don't.
I like the review quest.
Yeah. Yeah, we didn't learn that. So don't worry about 68. I thought bad 68. I thought they gave you more. They're using trig functions to cancel out a variable, and we don't need to do that.
Alright, see, I'm good with all these particular vectors. Like,
All right, so chapter 3, are we good?
I'm good.
Okay.
It's all about
GTG.
That, it's all about that.
It's all about forces. All right, let me
Get forces.
start a new video here.
I did number